All right, so today we're going to be building on our last episode of moving average crossover strategies and taking that to our first actual technical indicator, which is the moving average convergence divergence. Very popular, um, very widely used technical indicator. The moving average convergence divergence is an extension of moving averages, and it's used to explain trends more or less. So when the fast signal line has crossed over the MACD line, then that suggests bullish momentum. And the same thing for bearish, where if the MACD line or the signal line crosses below the MACD line, that is bearish. So we're going to be testing a strategy based on this at the end of the day. So let's get started. I'm putting side by side the new MACD code and just like the last episode, we're going to be defining our moving average fast and slow lengths, which by default are 12 and 27. I forget the name of the person who created this technical indicator, but those are the values that he decided or the best to use for this analysis. And then our look back window, just to start off, is going to be 100 days. And we can add to that later on if we decide we need more. And once we run it with our virtual environment set up, let's see what we get. Good, just a bunch of check marks. So let's take a look at our data frame. It doesn't know what it is because I have not defined it using the get data function. Data frame equals get data. And we don't need to put our ticker in there because it's defined within the function, but we're just going to do it anyway. Ticker is what we use to globally define it. Get rid of this. Okay, so let's move on to defining our MACD. Before we get started, we're going to add the span at 9. You will see what that means later on in the process. But for now, let's start defining our function to add the moving average convergence divergence to our data frame. We're going to have the fast moving average length, the slow moving average length, and the span, which is a moving average of the difference of those first two values. Sounds like a mouthful at first. Once we define each individually, it'll make perfect sense. So MACD fast is the global variable, MACD slow is the global variable for that. I'm going to get rid of those first words here in a second. That's just a bit too much typing. When you're coding, you want to have the smallest possible variable names. It's just best practice, and I still have not mastered yet, but we're getting a little better every day. So now we have all the information needed to make this function. So data frame, and we're gonna use an F string here to make sure that it is always referencing the exact length that we add to the function. So fast moving average or exponential moving average. And we're going to use EMAs today instead of simple moving averages just because that was widely requested and it's standard practice when building the MACD. So the way we make moving averages exponential is just by writing a slightly different function. We use EWM instead of dot rolling and span instead of just, actually we could just put the number in, but to be more clear, I'm saying span, and dot mean. So the span is how long you want the rolling average to be. So that we're doing fast and slow EMA of the close price dot exponential weighted moving average. Span is fast for the fast one and span is slow for the slow one. Dot mean to take the average of those rolling spans. Awesome. And we don't want that global variable there, but I will keep it just while I keep writing. And now for the MACD line is the moving average of the difference of those first two moving averages. So we just take the fast moving average and subtract the slow moving average from that. Both of them are exponential. Let's keep that in mind. Great. This one minus this one. Just paste that in. Awesome. So now we have the moving average convergence divergence value, but that's not the whole thing yet. That's just that's part of it. So we're going step by step to make this whole indicator work. And this all may seem very familiar if you watch the crossover strategy video. We define our first two, and then now we're just building on top of it. So MACD is the difference between those two, and the signal line is the 9-day moving average of the difference between these two crossovers. Again, sounds like a mouthful, but we're just doing it step by step, and this is the last one here. So let's take a exponential weighted moving average of the MACD column that we created. Is the data frame MACD column .ewm. Span is going to be 9, which we defined at the top there. Or we can just do it as span because we have that embedded in the function. And then take the mean, and we're all good. So now we have the MACD column and the signal column, and if we plot those two, it's not going to look quite as informative as we want. And I'll show you a bit more on that in a little bit. For now, let's make our main function that runs all of our functions at once. So get data, and then add the MACD, and return the data frame. What does our data frame look like? Great. So we have both of our moving averages, 12 and 27. We have our MACD, which is the difference between those two, and the signal, which is the 9-day moving average of the MACD. We can tailor all of those values. We can change 12 to be any number we want. We can change 27 to be any number we want. And we can change the span to be any number we want. So 12, 27, 9 is default, but choice is yours. Now that you can code, you can just change that number, take a look at a different approach to the same strategy at your will. It's all up to preference. Let's make a plot of what we have so far to get a little bit more information about what we're looking at. And part of the reason I take you guys through building the indicators step by step, detail by detail, instead of just adding or for example, installing a package or a library that could just add these to your data frame automatically. So you could just write in a function, add moving average, and then you would have no idea what's going on behind the scenes. Part of the reason I'm teaching you how to build these independently is because it shows you that by modifying details of it, it's equally difficult to gain an edge. And eventually, if you start changing the details yourself, you'll start to realize that the default or expected values that are preferred by traders are pretty arbitrary. If all of these combinations of values are equally ineffective, or maybe you find an effective one, but if we're just assuming that they're all equally ineffective, you'll start to realize that a lot of these indicators start to seem really useless, and you might start to seek out more advanced ways of gaining an edge. But that's much later down the line. For now, this is a great place to start. So here's a plot of our moving average convergence divergence lines, but this is never how it is actually used. So the signal has nothing to do with the raw values of these moving averages. So this chart would look like a lot of noise, essentially. What people usually do is they take a histogram of these two lines. So when the blue line is above the orange line, that is upwards momentum, and below, that is downwards momentum. A crossover is supposed to be a strong signal to enter, and vice versa, to exit if there's a negative crossover. So let's modify our MACD function to include another column that can provide us values for a histogram. Very easy. If you've been following along for the rest of this, this is the easy part. So data frame MACD hist is going to be simple. It's just going to be the data frame of MACD minus the data frame of the signal. And so those values are going to be what are plotted in our histogram. And if we plot, let's move this plotting function up to our MACD function, so it's always showing what we have and never change the title to MACD histogram, get rid of one of these columns, get rid of signal, and then just call the plot on the MACD histogram column of the data frame that we now have. Great, but that doesn't really look like a histogram, so we're going to make it a bar chart. Hist will not work. Let's do bar. What's wrong here? We need, so when you're making a bar chart, you need X and Y axes, and if you just have one argument, it won't know which one to do. So height, MACD hist, that doesn't work, because we also need to define the index. So we're going to make the x-axis the data frame index, which is a date time index that is set by default on Yahoo Finance. So separate those two x and y axes by a comma, and there we go. Now we have the full histogram. Awesome. And that's just 100 days. It's a lot of noise. So let's change this to 40 to make it a bit more likable. And it looks a little funny. There's some spaces between the lines. That's because there are weekends. So there's 2 days in a row where there are no values according to the x-axis that we defined. I'll change that a little later, but for now we see the MACD histogram. Great. So you see this often displayed below people's trading charts, and when there's bullish momentum, people take long trades, and bearish the opposite. But this is just a good visualization of how you can code yourself something you might see automatically input to your trading interface. So congratulations, you now know how to make this by yourself. It's much more powerful this way when you know what's going on under the hood. You can change every detail of it to your preferences. So let's start making a strategy around this indicator. What does that mean? People usually, as I said before, follow crossovers, just like any other strategy, to suggest changes in bullish versus bearish momentum. So when the moving average convergence divergence histogram is above 0, that is bullish, and below, that is bearish. Very easy strategy to code, just like last time. We're going to take a long position when the signal line is above the MACD line, and we're going to take a short position when the signal line is below it. So let's get started building our strategy function. So we're going to define the strategy of our data frame and then return the data frame after we assess what we want to happen. So data frame strategy is going to, by default, start at 0. That's just going to be a placeholder. And then we're going to use numpy to change the values in our strategy column. So np.where the signal line is above the MACD line, we will take a long position denoted by 1. Otherwise, we're going to denote it by a 0. Very simple, one line of code defines our strategy here. So MACD hist greater than 0 is 1, otherwise -1. Awesome. So that tells our testing function that we're going to make later on what to multiply the cumulative returns by. So data frame equals strategy. Let's make it add strategy just to be more consistent. Add strategy, then make the name of the function add strategy. There we go. Great. So now we have a strategy column that's a -1 when the signal is below the MACD and +1 when it's above. Super simple, super easy to write. And now we're going to go on to test it. Before we test it, I'm going to get rid of those gaps in our histogram by using the range function in Python. What it's going to do is just take those weekends and remove them and replace it with a range of the length of the data frame. So range provides a list of all values within a given list. So the length of the data frame is a number, and the range is all of the numbers within that length. A bit of a bad explanation, but now you can see that there's no more gaps because we just gave the value of every number between the start and end of the data frame for the index. Awesome. Now let's move on to testing the strategy of the data frame, and it is going to be data frame asset cumulative asset cumulative equals, and we can copy this from our old function in the crossover strategy code. So it's the same exact idea, and that's why I love this process. It's always just going to be the asset cumulative returns versus the strategy cumulative returns, and the strategy cumulative returns are always just going to be 1, 0, or -1 depending on short, long, or cash, and you can just multiply that by the asset cumulative returns column that you create. Great. So now we have the entire test strategy function. Let's add that here. df equals test strategy of the data frame. And there we go. Let's put this back here and run everything. Looks like we're all set. Get rid of that. All right. So now, yep, we've got those two columns at the end there. Not very clean because we're using a print statement. What happens if I just use Jupyter to display it? There it is. The last two columns are the cumulative returns of the MACD strategy that we have, but there's a problem that I can already see because I've been doing this for a long time. They're going up and up and up every single time, and that's because it's assuming we know the close price of the following day because we forgot to shift our strategy back one day. We can only understand data after it happens, so we need to use strategy.shift 1 to make sure that we're not peeking into the future at any given moment. Great, so now those values are the same because I forgot to run this. Let's run this here. Good. That looks a little bit more realistic. Now let's plot our returns. Let's plot the cumulative returns of the asset and our strategy to see how this does. Right now our look back window is 40 days. So what does this look like over 40 days of backtesting? plt.plot, plt.figure. We need to make a new one because we already have a plotting function in the same cell. So let's do plt.figure to make a new chart. And then plot the asset returns, copy this code, paste it below, and then strategy returns. We'll just do a legend actually. plt.legend is going to be an f string with the ticker, and then we're going to make another f string with the 3 values of the moving average convergence divergence that we used to make this strategy. So the ticker cumulative returns, separate that by a comma and put this in. So here, separate it, and instead of histogram we're going to do cumulative returns. Great. So when we run this we should see 2 plots, one for the histogram and one for our returns. Nice. So you can see that these returns actually outperform just a little bit. over the course of 40 days. But now we have the ability to backtest a little further. So let's move this. Oh, it was 30 days. Let's bump this up to 100 days. How does that work out? There's our histogram. Those crossovers are when we change our positions. And look, we're still outperforming by a little bit. We went on a big run there towards the middle. Awesome. And great, over 100 days, the MACD still does better than the index. So if you're backtesting for 100 days, that's good discipline, and you might feel confident enough to take the trade. But nobody's backtesting for 10,000 days. And now we have the ability to run that test using code with one click of the button, just changing the look back from 100 to 10,000. Quick type of a number. So let's see how it works. A lot of information has to plot here. All right, and oh, well, that's no good. You pretty much lose all of your money while everybody else is making 20x what they started out with. So when you take a further look at the moving average convergence divergence by itself as a standalone tool, just like every other technical analysis tool that I've tested, this does not work. So people refer to it as a very powerful tool, but on a standalone basis, when used how it is designed to be used on its own, you lose all of your money using it. So be careful when you are going about programming your strategies, and make sure you test everything like this. So you can do all of this yourself. You now have full authority to test your trading strategy on a level that is infinitely superior to anything you might have been doing for free on TradingView with your eyes and hands. Imagine if you were still doing this manually and you backtested the MACD 100 days, you would still believe it worked. But now that you have the ability to test 30 years with the same amount of, you understand a lot more clearly how effective this stuff really is. So we're going to be moving on to another technical indicator soon. So stay tuned to see how that works. And maybe we might use these in harmony with one another to see if there's a confluence between two strategies. So stick around. Thanks for following along, and I'll see you in the next episode. Stay sharp.